Welcome, Science 10. The last experiment you're going to be doing with the reaction rates unit is called blast off. You'll get a real bang out of it. It's on pages 276 to 277 of your textbook. The purpose, to make a timed explosion occur, and your hypothesis will simply be, do you think you can or think you can't make an explosion go off in, let's say, 10 seconds or 20 seconds, etc. So the format will be, I believe that either you'll have can or cannot, in this blank right here, be able to make the canister blow off at a specific time. Background. So we're going to look at the things you have been experimenting here, the factors that affect how fast or how slow a reaction rate happens. So for example, different temperatures of water, different surface area of reactant, and of concentration, how much tablet. Now, if you look in the textbook, you will be using Alka-Seltzer tablets again, and you'll be placing them in water, as per textbook, and what you'll be using is one of these film canisters, one of these old school film canisters that are getting very, very difficult to find now. So of course they have a lid that comes off here. The ones you'll be using look more like this one. They're the clear plastic ones with the lid. It's nice because in the lid you can place the tablet here, place the water in here, then flip it over. It holds the tablet really nice, whether it's powdered tablet or tablet chunks. So it works out really, really well. So yeah, that's what you'll be doing. You definitely need goggles because these lids blow off at quite a high speed, and if they hit you in the face, it could hurt. So you need to figure out, a lot of this experiment is going to be what you decide to do or what you design. So measure out a specific amount of water. So you should likely label or keep track of how much water are you using. I put just half full here as a recommendation, like have the canister half full, but how many milliliters is that? So you should figure out which volume you're going to use by using a graduated cylinder and actually measuring it out each time. I recommend taking a tablet, dividing it into fourths, and then working with those, because I'm only going to give you a maximum of 2 tablets to work with. That's it. And you need to save 1 piece for the final test, because you'll be experimenting, writing down times, and then I'll come around and say, okay, I want you to make the tablet, or I want you to make the explosion occur in X number of seconds. So you have to have enough tablet left over to do that. So recommendations that you could experiment with. So you could use different amounts of tablet. Are you going to use a really small chunk or a bigger chunk? What's the mass of it? So just place it on the mass there. Consistency. Are they going to be one chunk divided into several chunks, or that one chunk powdered? So tell me about that. What temperature of water are you using? What volume of water are you using? And then after, how long does it take to explode? So once you put the tablet in with the lid on, how long does it take for this to happen? Okay, you don't need a lot of tablet. A lot of people put in half a full tablet and then it's over. You used up a tablet. So just use pieces. You don't need a lot because these film canisters are small. The conclusion, just the usual here. The purpose was to your hypothesis. It was thought that and then what happened? Were you able to make it go off at a specified time? And that's what you'll find out. Follow-up questions. The tablet in there, is it a chemical change? What evidence do you have that that was a chemical change? Number 2A, what variables did you test with? So to figure out the rate of the reaction, what did you use? And then which variables did you not use in the experiment? Because once again, these are recommendations. You don't have to do all of these. And then lastly, number 3, if you had more time, how could you improve this experiment if you had given more time and possibly more material? So you can think about that too and answer that question. Okay, and that's it. It's a really fun lab. You'll have a bang out of it. So this is the last one of the reaction rates unit. Good luck.